Alright, so today we're going to talk about adding and subtracting and multiplying radical numbers. And the first thing we got to do is you must simplify all your radicals. That's step one. Once you do that, any radical with the same index and the same radicand, basically the same thing inside the radical, you can combine those terms. For when you do that, all you do is add and subtract their coefficients, and you keep that common radical. So let's go ahead and do some examples. All right, so let's take a look at the first one. So the first thing we got to do is we have to break down the square root of 27. So when we do that, again, birthday cake, so I'm going to do 3, 9, 3, 3, 3, and 1. Look for pairs because the square root. There's a pair there. You already have that 3 on the outside, so it's basically 3 times the pair of 3's that you just did, square root, and what's left is this 3 here. And we're going to subtract, and you got to do the same thing for the 12. So we got to do 12, we're going to do 2, 6, 2, 3, 3, and 1. And we have a pair of 2's there. But again, you have that 2 on the outside already. You're going to bring out that one pair of 2's. And what's left inside is the square root of that 3. And you can see, so let's go ahead and multiply them. So you get 9 square root 3 minus 4 square root 3. And you see how they have the same exact radical here. If that's the case, then all you have to do is subtract their whole numbers in front, which is 5, and you get 5 square root 3 as your answer. All right, same thing for the next one. Okay, you got to break down each one of those. So 54 is the first one. So first thing you got to do is divide that by 2. That gives you 27. And then 3, which gives you 9. 3 again, which gives you 3. 3 again gets you 1. This time we're looking for groups of 3 because our index is 3. So there they are. So this would be 3 times the number on the outside that you're pulling out, which is 3, cube root of 2. Minus. Now, if you look at the cube root of 2 here, there's nothing you can do with that. So that's just going to stay as 2 cube root 2. And then same thing on this back one. You got to do negative 16. Okay, so let's do that. 16. That's 2, which gives you 8. You get 2 again, which gives you 4. You have 2 again, which gives you 2. And you have 2 again, which gives you 1. Again, you're looking for groups of 3. So plus 7 times, now that 2 that comes out, because of the negative inside, is going to be a negative 2 that comes out. And what's left is the cube root of 2. So you see how they all have the same exact index, same everything. Okay, so that means that we can add them all together. So let's go ahead and you get 9 cube root 2 minus 2 cube root 2 minus 14 cube root 2. So 9 minus 2 is 7, minus 14 gives you negative 7 cube root of 2. Getting letters involved doesn't change anything really. So we just do the same process that we did when we did simplifying. So you get 98, you can divide that by 2. And you get 49. And the only thing that goes into 49 would be 7 and 7. There's your pair, so that's going to come out as a 7, the square root, and then the 2 is going to be left in. Okay, same thing for the letters, right? So the exponent is 4. Again, you're going to divide that by the index of 2. 2 goes into there 2 times with a remainder of 0. So that means 2 x's will come out. Same thing for the y. The exponent is 2. The index is 2. So 2 goes into 2 once with a remainder of 0. Okay, so that means 1y is going to come out. You're going to bring down your negative 3x squared y. And remember, when you do letters, they have to be the exact same looking terms. So if we look at these front terms, x squared y, which means now I can subtract them together to get 4x squared y. And then your square root of 2 just comes down, and there's your final answer. All right, same thing for this last piece down here. So we'll do each one again. So we got 40. Break it down. 2 goes into that 20 times. 2 goes into that 10 times. 2 goes into that 5 times. 5 goes into that 1. So you're looking for groups of 3, which is there. So negative 2 is going to come out. And the 5 is going to stay in. Okay, if you look at the letter, 7 divided by 3, 3 goes into 7 twice with a remainder of 1. What that tells me is 2 A's come out, 1 A stays in. And then same thing for this next one. So we're going to do 135. Which you can divide by 3 to get 45. Which you can divide by 3 again to get 15. Then you can divide by 3 again to get 5. And then you can divide by 5 to get 1. Okay, but you already got that 2A squared out there. So then that 3, like for that group of 3's there, comes out. The cube root there of the 5 stays in. Okay, then you got that exponent of 4. When you divide by 3, it's 1 with the remainder of 1. So that means 1A is going to come out. And 1A is going to stay in. All right, so let's go ahead and do this. So you get negative 2A squared, cube root of 5A. When you multiply those, you get 6A to the 4th, cube root of 5A. And if they don't, so you got A to the 4th here, you got A squared here. They're not the same, so that is the final answer. There's nothing else you can do. For multiplying, you just multiply their insides together and then simplify from there. So let's go ahead and go to that. So as long as they have the same index, you can multiply them together. So if you look here, I can multiply outside to inside, so that's going to give me 10. And then inside to inside would be negative. Negative 216. And then you break down 216 from there. So we're dividing that by 2. Get 108. Divide that by 2. Get 54. Divide that by 2. Get 27. And then you can divide that by 3 to get 9. 3 to get 3. 3 to get 1. And because the cube root, we're looking for groups of 3. We have a group of 3 there. And a group of 3 here. So it's going to be 10 times the group of 3 there, which is 2, times the group of 3 there, which is 3. And there's nothing left inside, so and that's going to be negative because of the negative that's inside. So you get negative 20, negative 60. Okay, same thing for the next one. Outside gets multiplied to inside, outside, so that gives you 3. Inside gets multiplied to inside. Which is 512. So when we break down 512 divided by 2, you get 256. Divided by 2, you get 128. Divided by 2, you get 64. Divided by 2, you get 32. Divided by 2, you get 16. Divided by 2 to get 8. Divided by 2 to get 4. Divided by 2 to get 2. Divided by 2 to get 1. So we're looking for groups of 2. So you got 1, 2, 3, 4. 4 sets of 2. So all those are going to come out. 1, 2, 3, 4. You're going to multiply them all. And what's left over is the 4th root of the 2 that's left over. So 3 times 2. But 2 times 2 times 2 times 2 is 16 times 3, which is 48. So my final answer would be 48, 4th root of 2. Okay. Same thing for the last two. Same term, so I can multiply them together. So 36 times 3 gives me negative cube root of negative 108. Remember, you add exponents when you multiply them. So 7 plus 6 gives me an A to the 13th, and then B to the 6th. So then we break down 108 divided by 2, which is 54, divided by 2, which is 27. Then divide by 3, which gives you 9, divide by 3, which gives you 3, divide by 3, which gives you 1. Looking for groups of 3, there it is. So that 3 is going to come outside. Okay, and you got the cube root of the 2 times 2 that's left over, which gives you 4 on the inside. And remember, because it's negative, the negative comes out. Then you got to deal with the letters. So you got to do 13 divided by the index of 3. Well, 3 goes into 13 4 times with the remainder of 1. That means 4 A's come out, 1 A stays in. Then you do the same thing for B's. Okay, 6 is in, divided by the index of 3. That's 2 with the remainder of 0. That means 2 B's come out. Nothing stays in. So there is your final answer. And same thing for the last one. Okay, multiply outside to outside, so that gives you 14. And then you got to add the exponents of the letters. So p squared times p to the third would be p to the 5th. Q times q to the 10th is q to the 11th. Okay, since we have no numbers inside, we just have to worry about the letters. So 4 goes into 5 once with the remainder of 1. So what that tells me is that 1p comes out and 1p stays in. Then you got the 11, and that's going to be divisible by 4 again. So that's going to be a 2 with the remainder of 3, which tells me 2 q's come out and 3 q's stay in.